Welcome to Lesson 6, Activity 6.2, Thermal Energy of Solids. So, our learning target for today is we're going to connect ideas about temperature, kinetic energy, thermal energy, and molecules. So, the expectation for you is that you're able to connect the ideas about the temperature, how does it relate to kinetic energy, and how does it relate to thermal energy and molecules. So, ideally, you'll learn about the connection between all of those and be able to explain those in class. Now, first of all, let's talk about matter. What is matter? Do you know a definition of matter? Do you know what matter is? Well, our definition we're going to use is matter is anything that has mass and it takes up space. So matter exists in different states such as solids, liquids, gas, and plasma. Now, which of those four, solids, liquid, gas, and plasma, do you find most common here on our planet? Well, if you answered all of them with the exception of plasma, you're correct. So plasma is not commonly found on our planet, but we find solids all the time, liquids all the time, and gases all the time. Now, are you matter? Well, let's look at it. Do you have mass? Yes. Do you take up space? Yes. So you are matter. How about air? Do you think the air around you is matter? Does it take up space? Well, we can walk through it, but let's pretend once we had a balloon. Could we blow up the balloon with air? Yep. So it does take up space. And believe it or not, air also has mass. If you took a balloon and you put it on a balance empty and you put it on a balance after it was blown up, it should have a little bit more mass to it. Now, what are the differences between the states of matter and what are they all made of? So this is what we're going to be exploring today and in a few other lessons that we go through. So what do you think? What are the differences between the states of matter? We're going to explore solids today and we'll explore liquids and gases at a different time. Are molecules stationary or in continuous motion in each state of matter? So what do you think? We're going to be able to answer that question shortly. And to answer that question, we're going to be looking at a computer simulation. So it says, watch a computer simulation that demonstrates the molecular motion in a solid. And then we're going to look at another one. We're going to raise the temperature of it. So what we're going to do is we're going to do a computer simulation right here. So I went to the link. And, oops, sorry. Let me find the right one. Actually, we're going to pause. All right, sorry about that pause. I just had to find the right one. Okay, so here we have an anvil. That's right here. You know, it's like what a blacksmith works with. And right now we're looking at the molecules in this anvil, in this solid. And this is a microscopic look. We can't see this with our eye. We can't see this with the microscope. But if you were to look at this solid is made up of individual molecules that are all moving. So even if you looked at your hand appears to be a solid, but if we were to zoom in and zoom in and zoom in some more, eventually we would be able to see the molecules that make up our hand and they would be moving. So what I want you to do right now is look in your book on page 67. Are the molecules inside the solid stationary or in continuous motion? And what energy do molecules have? So go ahead, answer question number 1. So pause the video and then answer question number 1. All right, so you've answered question number 1. Now number 2 says, what is the difference between the molecular motion of a solid at a high temperature and the same solid at a lower temperature? So what I'm going to do down here is I'm actually going to raise the temperature. So watch what happens as the temperature goes up. What's happened to the molecules? So again, what is the difference between the molecular motion of a solid at a high temperature and the same solid at a lower temperature? So here's the higher temperature, and let me go back down. As I'm sliding this down, what's happening to the molecules? Again, if I go up, and then I go back down. So go ahead, pause the video and answer question number 2. All right, now that you've had a chance to answer questions 1 and 2, let's look at the conclusion. It says the thermal energy of an object is the sum of the kinetic energy of all the particles in the object that results from the random motion of the particles. The greater the kinetic energy of the molecules, the greater the object's thermal energy will be. So why do you think we use the word kinetic energy here? What did we notice about those particles? They were moving. So thermal energy basically is a type of KE, or kinetic energy. So answer this question for me. When does an object have more thermal energy? When it's hot or cold? And why? So go ahead, pause the video and answer that question in your book. All right, so what did you come up with? Again, we'll go over this in class, so hopefully you have this done by the time we get to class, or if you're absent and you're catching up, just show me your work and then we can discuss it. We can go over it if you have any questions with it. All right, so now we have one question left, a follow-up. Do all solids have thermal energy? Why? So go ahead, pause the video and answer this question. All right, so let's review quickly. Until now, we've learned that only moving objects have kinetic energy. But now we see that even when an object is stationary, the molecules the object is made of are indeed moving. Now, a ball may not be moving, but its molecules are. So we got to be careful when we're talking about objects in class. The ball itself may not be moving, but its molecules are. Now remember, thermal energy, and we'll call it TE, is a type of kinetic energy due to its molecular motion. So is every solid made of molecules and atoms? Yes. Do molecules and atoms move all the time? Absolutely. Scientists have never been able to completely stop molecules from moving. They've come very close, but they've never been able to completely stop molecules. Does every solid have thermal energy? Well, yeah, a very small amount, some of them do, but they all do have thermal energy. And when does a solid have more thermal energy? When it's hot or cold? And why? Well, typically when it's hot. Now, if we look at total thermal energy, we have to look at how much of the object there is as well. But if you have the same amount of mass, a hot object will have more thermal energy than a cold object. So this is completed activity 6.2. Again, if you are absent and you need to show this to your teacher, make sure you show it to your teacher so that way they can mark it off as you being done. And remember to ask your teacher any questions you have concerning this activity. Not that we get to the test and all of a sudden you don't understand some things because you never asked. Okay, thanks for finishing this up. And again, remember to show me. Bye.